Okay, our objective today, 6th grade, is to start chapter 5, okay? In my mind, chapter 5 is kind of in a weird spot of your book, so let me just tell you a little bit what it's about. We're going to talk a lot about rational numbers and equations. So I know in chapters 2 and 3, I already gave you guys and girls equations that had fractions in them. I made them more difficult. The book did not. So this is their time now where they give you equations and expressions that have fractions. A lot of this, especially the beginning, I'm not going to have you use a calculator on, okay? There are also some problems towards the beginning of the chapter that we are adding and subtracting fractions with like and unlike denominators. Okay, so that's another big part of it, as well as converting mixed numbers to improper fractions, which you've already done a lot. So today's lesson, at least most of it, should be pretty much a review for you guys. Yes, the chapter does get harder, though. Today's lesson is just an overview. I am thinking as long as we stay on track, you'll have a quiz right before break, just halfway through the chapter. When we get back from Christmas break, we'll finish up chapter 5, do a review of the whole chapter, probably for 2 days since we have Christmas break between it, and then we'll finish that up. So your next cumulative exam will not be until after chapter 6. So I'll do that after every 2 chapters. Okay, you don't need it after every one. Okay? All right. So, lesson 5.1, the objective is to write fractions as decimals and vice versa. So, we're going to do it both ways without a calculator. Okay, some of it's easy, some of it's a little confusing. We'll get through whatever we have time for. Okay, no calculators though. You can check with it, but we're going to do most of this by hand, which I know is what the 6th grade classes, a lot of them do this in September. Your book just has it now in chapter 5. Okay, so let's go over our warm-up. Kind of an interesting question here. If you guys can't hear me, let me know since I'm a little stuffed up. So 1, 2, and 3 say write the number as an improper fraction. So Justin, how do we do that for number 1? Good. Why is that an improper fraction? Justin, do you know why? Yep. Numerator's larger than the denominator, so it's an improper fraction. Mary, what about number 2? Okay, can you tell us how you got that? Awesome. 9 times 5 is 45, plus 2 is 47, over 5. Improper fraction. Briar, number 3. Good. 37 over 3. Again, Briar did 12 times 3 is 36, plus 1 is 37. Leave it over the current denominator, which is 3. Adam, number 4. Awesome. 0.53. Go ahead. Perfect. That works. There's a lot of answers you could have for these. Sean, did you have something different? Okay. Sean, go for it. Good. And if you left it as 4 over 10, I'm okay with that as well, because it's just not simplified. Okay. Doug, number 6. Good. Did anyone have the simplified version? Sean? Good. You could also have 9 over 25. Emma? Yes. Go for it. Should be positive 4th, because to go from 7.62 to get back to the expanded form, you move it to the right 4 places. 1, 2, 3, 4. Okay? To get it smaller, Emma, it's negative. You have to move it back to the left. Okay? Annalise, number 8. Awesome. What did you have to remember about this number right here? What does it have to be between in scientific notation? Always, Alyssa. Good, 1 and 9. So it can be 9, it just can't be 10. It could be, the C value has to be greater than or equal to 1, but less than 10. So it can be anything less than 10. Matt, number 9. Thank you. Okay, number 10, Emma H. Good job. Okay, questions on the warm-up. Annalise? You tell me. Yeah. Yeah, you can't change the value of it. For example, if you did 15 over 2, That's not 15. Yeah, you cannot change the value of it. Whatever you write the improper fraction as, it still has to reduce to 15. That makes sense? Okay, anyone else on the warm-up questions? Okay, so flip over to page 3. We have 3 definitions to talk about. In my opinion, they're pretty basic. We just need to have a discussion about them before we actually get into some examples. So the first one is rational number. We talked about this in chapter 1 because I added in types of numbers into that chapter. So rational number is a number that can be written as the quotient of 2 integers. A rational number is a number that can be written as the quotient of 2 integers. So a fraction is a rational number, a mixed number, a repeating decimal, an integer is rational, a whole number is rational, natural number is rational, a perfect square is rational. So there's a lot of things that we talked about that is an example of a rational number. Annalise? Yeah, remember, a rational number could be 2.3. That's rational. 4.1 repeating. That's rational. Any nice decimal that either repeats, Annalise, or has a pattern is always rational. So yes, and we learned that back in chapter 1. Okay, a terminating decimal. This one sounds kind of cool, huh? I'm sure you've learned of this before. A decimal that has a final digit. So a terminating decimal, a decimal that has a final digit. They do not. Well, I guess you could kind of think of it. A repeating decimal keeps going, though. So repeating decimal does not have a final digit. Technically, even though pi keeps going randomly, it does have a final digit because no one has discovered the next numbers yet. So, Adam? There is. Mm-hmm. But the point is, it keeps going. So who knows what they'll discover or change their mind about when they do find the next couple ones. You know, Alyssa? They have some crazy formula. We'll have to look that up one day because I don't know the answer to that. Yeah, they're obviously using a circle for it, yes, but I would like to see what that formula is that they're using. I'm not sure. Okay, guys, are these questions related? Okay, if it's sort of, then no. Sean, go ahead real quick. Oh. But now you know. Good. Annalise, is this related? Good. Okay, hold on. I'm getting to that. That's the next definition. Charles? Well, you're not worried about the zeros. They're not doing anything. Nice try, though. And Charles, we could use that for that excuse could be made for any number, like 4. 4.0, it could go on to infinity with the 0. We're not worried about the 0. That's not changing the value of anything. These are terminating decimals because they end. 3/4, 1/4, okay? 0.125, 0.75, 0.25, they end. We don't care if we add on zeros. They are terminating because that's it. Okay. Since you guys are all asking me about that. Okay, repeating decimal. A decimal that has one or more digits that repeat without end. So repeating decimal, a decimal that has one or more digits that repeats without end. So 0.3 repeating. The 3 has a bar over it. It repeats forever. It keeps going. 0.94, the 94 repeats. So 94, 94, 94, 94, 94. And I could keep saying it all class period. Keeps going. No, it never ends. It's a repeating decimal. It keeps going. Charles? Okay, 0.13 bar. That is a repeating decimal because it starts with 0.1 and the 3 goes on forever. Still repeating decimal. Anything with the hat on is repeating. Mary? Okay, you're right. Okay, not related. You're right. Annalise, is this related? That's not going to happen. That can't happen. The calculator rounds it. I think you're thinking of the calculator. The calculator can't fit all of the infinity repeating, so it rounds the last number up or down, depending on what it is, because it can't keep going, and it doesn't make the hat. Okay, Sean? Right. That doesn't make sense. Right. Right. Justin? Correct. Yes, exactly right. Emma? Yeah, you could have that. Kind of rare, but you could have it. Okay, so rational, terminating, repeating. Terminating decimal ends, repeating keeps going. Okay, so let's get to some examples. So you kind of had this as your warm-up, but let's do this again. Example 1, show that the number is rational by writing it as a quotient of two integers. We're in the blue packet, page 3. Okay, so 3. There's a couple ways to do this. Doug, what's one way to write 3 as a quotient of two integers? Say that again. 3 bars? 0.3 bar is 1/3, not 3. So no, because you're changing the value of it. How can you write 3 as a quotient of two numbers? We did this in the warm-up. Okay, Alyssa? Say that again. Good, 3/1. What else? What's another one? Adam? Good, 6/2. So anything that still is 3, but you're writing it as a quotient of two integers. Okay, letter B. Annalise. Sorry. Good. 48/-4. I was writing that wrong. Perfect. That's one. What's another one? Adam? Good job. So there's a lot of them. We could even have -12/1 to keep it simple. Okay. Sean, letter C. Go ahead. Yep. Correct. Why? Yes. That would equal a positive. Good job. Okay, letter C. Good question. Letter C, Emma H. Good. 14/3. Hey, Adam, hold on. You got to raise your hand. Hold on, Adam. I'll get to you. What's another one for letter C? Matt, what's another one? Good. 28/6. Okay, Adam, what's up? It's repeating. It's rational. 2/3 is 0.6 repeating. That's okay. That's okay. It's a good review of rational numbers. I'm glad you're thinking. Charles? Okay, go ahead. Good job. Okay, why does that work? Why does that work, Mary? Yeah, two negatives equals a positive. Okay, letter D. Briar, what about letter D? Kind of 9/4. Good. -9/4. Anyone have another one? Justin? Good. -18/8. Okay. Any questions on those four? They're pretty basic. Annalise? Yeah, no. Ignore the negative until the end. You ignore the negative. 2 times 4 is 8, plus 1 is 9. Then you throw the negative in front. You ignore the negative until the end when you're changing a mixed number to an improper fraction. Okay, anyone else? All right, fun stuff's coming up. Are you ready? No calculator. Time for long division. We need to change 5/16 to a decimal. Who remembers how to use long division? What goes in front? What goes on the inside? I know it's probably been a while. Briar? Nope. Opposite. 16, the bottom number goes on the outside. The numerator goes on the inside. All right, well, now what? We can't put 16 into 5. So what do we do here? Alyssa? Good. So 5.000. Let's just draw 4 zeros. So when you divide, just as a reminder, that decimal point just drop right up. Kind of ignore it when we're doing long division, but leave that decimal point where it is. Just drop it right up. So you're going to ask yourself, and I'm going to put a 0 here because 16 does not go into 5. So you move over to the next number. How many times does 16 go into 50? Mary? Good. So then you ask yourself, what's 16 times 3? Justin? Good. So you drop down 48, and we subtract these numbers. Do you guys remember this before I keep going at a slow, medium, fast pace? Okay. So 16 times 3 is 48, so now we subtract. 50 minus 48 is 2. Drop down the 0. Okay. 16 goes into 20. Charles, how many times? Good. Very good. I'm glad you sound like that's very easy. 16 times 1 is 16. Subtract it. 20 minus 16 is 4. Drop down the 0. 16 goes into 40 how many times? Briar? Good. Twice. 16 times 2 is 32. Okay. 40 minus 32 is 8. Drop down our 0. 16 goes into 80 how many times? Doug? Good. 5. Sean, what's 16 times 5, excuse me? Good. What does this mean? What does that mean? Mary? Good. It is a terminating decimal. So the answer is 0.3125. It ends because we have a remainder of 0. So it's a terminating decimal. If we check this on our calculator, I'm sure you know this, but let me show you just in case. I don't like to assume things. If you take 5 divided by 16 on your calculator, hit enter, it gives you 0.3125, which is what we just got using long division. It's an extremely important skill to remember how to use long division. So I know you guys are pretty good at this, but don't forget it, okay? Sometimes it's faster to do it that way as opposed to using the calculator, especially if it's a pretty small fraction. Mary, question? Okay, good. Oh, there you go. I like that. Yeah, box tops. It goes, yeah, I like that. Yeah. I just always remember the denominator goes in front, numerator goes inside, but that's a very neat way to remember it. Annalise, is this a question? It's just, it's kind of like asking, why do you write improper fractions the way you do? It's just, it's math. That's how you use long division. I mean, yeah. And, right. If it was the other way around, if it was 16 divided by 5, then it would be the opposite. So just, that's how you use long division. Emma H? Exactly. 5/16 is smaller than 1, so you know it's going to be a decimal. So use your math common sense. I completely agree with that. Adam? Yes. Yep. That one will be a little easier, of course. All right, let's do another one. So write 4/9 as a decimal. So Donatus, what goes in the front of our division symbol? Good, the 9. The denominator always goes in front. It's 4 divided by 9. After the 4, Briar, do you have a question or the answer? Okay, let's wait for that for a second. So 4.000, I'm just going to add 3 zeros. I just randomly decide how many zeros to add. You can keep adding them. I know you remember that. Okay, so Emma H, does 9 go into 4? No. So put a 0 up here. Bring your decimal point straight up, okay? Matt, 9 goes into 40 how many times? No. More than that. Okay, Matt, you're scaring me. What's 9 times 4? Good job. All right, now you're not scaring me. Okay, 9 times 4 is 36, so subtract. 40 minus 36 is 4. Drop down your 0. Briar, 9 goes into 40 how many times? Good. Charles, what's 9 times 4? Good. Emma M. Oh, geez, that's a subtraction sign. Emma M. 40 minus 36 is what? 4. Drop down the 0. Sean, 9 goes in. Hey, I'm having fun with this. Sean, 9 goes into 40 how many times? Good job. That was so tough, wasn't it? Annalise, 40 minus 36 is what? Good. Let's add another 0. Drop it down. Are you getting sick of this yet? Okay. We can keep going. Okay. What's my point of this? What kind of decimal, Charles? Okay. I know. Yeah. Okay. So our answer here, I'm just going to put a bar over all of them, but you could also write your answer as 0.4 with a hat above the 4. Okay? It repeats. Okay? It goes on forever. We could stand here for a half an hour and keep doing this. It's never going to change. Okay, Alyssa? Yes. Yes. I had to think about that. Mary? Shh, Briar and Adam. Okay, if you want. Okay, on task here. Don't ask questions that don't relate. Annalise, is this related? Okay, go ahead. Well, it's like 1/3. 1/3 is equal to 0.3 repeating. Just 4/9 is 0.4 repeating. I don't really have an answer to that. It is. Like, it's kind of like asking why is 1/4 0.25? Because that's how you divide. I don't know what else to say to that. Like, why does 2 come after 1? Because it does. Sean? Shh, shh. No, that's not true. You don't add them all up. Not quite sure what you're asking about, but don't think about that. 1/3 is 0.3 repeating. When you divide, you're just finding out what it divides into. You're not changing any of the decimals. Mary, is this related? Go ahead. Okay, let's go to example 4. Okay, example 4, writing terminating decimals as fractions. So I'm on example 4 on page 4. Okay, I'm skipping around a little bit because you guys are good at long division. So example 4, letter A, 0.03. Can you guys tell me what the fraction is of that? This is somewhat of a review. Justin? Okay, explain to us why you knew 100 was on the bottom. Good. 3 is in the hundredths place, so 3 over 100. If you convert that back on your calculator, it will tell you 3 divided by 100 is 0.03. Another way to check is to type 0.03 into your calculator, hit math, enter, enter, and it converts it for you. However, part of the Chapter 5 test, you may not use a calculator because I want you to do this by hand. Okay, I want you to know both ways. Okay, what about negative 9.4? So what about that one, Briar? Oh, well, you could still answer it. Negative 9 and 4/10, completely simplified. What is that mixed number? Yep. 4/10 reduces to what? No, simplify it. Not improper, simplify. Good, 2 over 5. Nope, simplify. Annalise? That's right here. That's right. You said you had negative 9 and 4/10. That's a mixed number. Oh. Okay, I mean, you can do that. That's fine. I'm going to leave it as a mixed number. That's fine. Doug? Annalise just said that. That's fine. Okay, let's go to example 5. I'm going to end on something hard. Okay, so you've never done this before, so I'm going to show you how to do this, at least right now. We'll at least do 1 or 2. Please let me do 2 examples before you ask anything because this is confusing. Okay, the more examples I do, the easier it'll be. So now we need to write repeating decimals as fractions, okay? So 0.81 repeating, they're asking us, change this to a fraction. Even if you know what it is, you have to learn the process. So what I want you to do is make a big fraction bar. Okay, in the numerator, you ignore the hat, write it as a fraction. So what is 0.81? Ignore the hat. What is it as a fraction? Ignoring the hat, Adam. Good. So on the top, you write 81/100. This little formula that I'm giving you always works. On the bottom, the denominator, 1 minus 1 over whatever place this is in. So on the bottom, 1 minus 1 over whatever place this is in. Okay, rewrite your numerator, 81 over 100. What is 1 minus 1 over 100? What is 1 minus 1 over 100? Sean? Good, 99 over 100. It's basically saying 100 over 100 minus 1 over 100. Because if you change 1 to have a common denominator, 100 over 100 minus 1 over 100 gives you 99 over 100. Hold on, Adam. Does everyone understand how to get from here to here? Okay, Adam, do you have a question? Oh. Yeah, that's what we're doing. Okay, so now we're dividing. Okay, keep, change, flip. 81 over 100 stays the way it is. We change division to multiplication, and we flip the denominator. So I'm going to write here, keep, change, flip. Keep, change, flip. What can we do here before I multiply? What can we do here, Briar, before we multiply? Good. What can we cross simplify? Good. They go into each other one time. What else can we cross simplify? Justin? You mean by 9? Okay. So it goes in 9 times. 9 goes into 81 9 times. 9 goes into 99 11 times. 9 times 1 is 9. 11 times 1 is 11. The answer is 9/11ths. So if we go to our calculator, if I type in 9 divided by 11, it's 0.81 repeating. The calculator just doesn't have the hat. This process is the formula you always can use if there's a decimal that's repeating. I'm going to show you one more. Charles, real quick. I want to do an easier one first. I'll do that one tomorrow. Okay. But you can do 0.25 with a bar above it. It works. Okay. Let me do one more, and then you can do that later, or we'll do it tomorrow. Okay. I have like a minute. Okay. The next one I want, where's your notes? Chapter 5 notes are in the back. Okay. Okay. I want to do this one. This is a random example, so wherever you have room, add this. 0.8 repeating. So I just want to do an easier one. 0.8 repeating. Okay, make a big fraction bar. Ignore the hat. 0.8 without the hat is what fraction? Alyssa. Good, 8/10. The bottom, 1 minus 1 over whatever place this is in. Always. Rewrite your numerator. What is 1 minus 1/10? Adam? Pretty soon you can do this pretty much in your head. Okay, so 8/10 over 9/10. We now do keep, change, flip. So 8/10, change it to multiplication, flip the bottom fraction, keep, change, flip. Emma M, what can we cross simplify? Good. What is the answer? Annalise? Awesome. I don't have time, but if you type that into your calculator, 8 divided by 9 gives you 0.8 repeating. Emma, real quick. Yes. You'll start to notice that this is easy to do in your head. I just have to show you the process. Annalise? Well, example 3 you don't need me to do with you. It's easy, so no, I skipped that. I'll probably do, like, the closing I'll probably do tomorrow, Annalise, but not example 3. It's just comparing them. All you're doing is using long division, Annalise, figuring out which one's bigger and smaller. That's all. Okay. All right. I need you. What'd you think of that? Those 2 problems I just showed you. Okay. We're going to do more of it tomorrow. Just curious. All right. No calculator on the homework. So open up your homework packet to 5.1. Adam, open it up. You are not doing all the numbers. So write these down or circle them. Excuse me. If you write big, I suggest using another piece of paper because you're not going to have room. So 1 through 16, 21 to 26, 29 and 33. I have to make one comment to you, so don't put this away yet. Look at number 25. Do you guys see 25, how it's negative 8.4 repeating? So ignore the negative 8. I'm sure you know this, but ignore the negative 8. Change the 0.4 repeating to a fraction, just like what we did, and then you just throw that in there. So you ignore the negative 8, change the 0.4 repeating to a fraction. No, well, yeah. Yes. Those are easier, though. The 23 and 24 are not repeating. Those are easier. Do not use a calculator. If it says to change it to a decimal, I want to see your long division work. Okay? Sean. Yeah. It's the easiest way to do that. Charles? I want you to, yes. I know it's easy, but yes. Yes. Annalise. Real quick, we got to go. Yep. Only if it's repeating. Okay, and Annalise, you're not going up to 28, just up to 26. Okay. Okay. Doug, hands. Got to raise your hand. No, there's not really any work to show for 1 through 8. Just the long division problems is what I said. Okay, anyone else? Okay, let's get packed up quickly, please. Make sure you have the correct numbers written down.